Moving into our 1.2 section, evaluating functions using our domain and range. We're looking at pictures a lot today, talking about domain and range. Over the last couple of days, I asked you to evaluate a function for f of 0 and f of 3, and I handed you the function. And we learned that that means that I'm just going to plug that number in for my x's and get an answer, right? Well, this one kind of has a combo of both, but you can also find a function value from looking at the picture. So I actually could eliminate this part of it and not tell you what the function is, give you the picture, and say, find for me f of 0. So how do we do it? Not being able to type it into our function, but looking at our picture. Well, f of 0, remember, this is our x's. And so I would go over here and look at where x equals 0, which would be along this line, and I would follow that line until we get to our graph. And my graph would happen right here. And that would be the point 0, comma, and we would finish that ordered pair from the graph. Well, that's about 0, comma 4. Okay, that's my answer. That is the y value that finishes out the point that started from the question. Okay. If it asks me to verify algebraically, it will have to give me the function, and they do in this particular problem. They tell me that f of x equals x squared minus 4x plus 4. So verifying algebraically is just plugging in for x, and I can do that. And what should happen is, if I actually see it correctly, my answer to this should match what we saw in the picture. So I should get 4. Well, 0 minus 0 plus 4 is 4. They match. I did a good job of picking out the right number for my picture. Okay? So let's try that one more time. Again, I want you to go based off of the picture and not off of the function. F of 3. So again, I come over to where x is 3, which would be this line. And if I follow x equals 3 up, I locate where that actually hits my graph, 3, comma, and I finish the point. And it looks like that's going to be at 3, comma 1. And if I wanted to check my answer or verify algebraically, then we just go plug it into the function. But again, at some point this year, I'm going to take this away from you, and you will literally only have the picture to look at, and that's how we go through it. Questions? Okay, then I'm going to have you try on your own. Yours is really hard to see, so I'm going to blow this up a little bit so it's a little bit bigger up here, and you might be able to see it up on my board, actually, better than you can at your seats. But I'll give you a minute here, check with your table partner. You don't need to confirm algebraically. Let's just use the picture. I don't want you to use the function. Use the picture for f of 0 and f of negative 1. Like I said, on your note sheet, it is really hard to see, a little bit easier on my board. And then if we're not sure and we have the function, we can see how well we did. So f of 0. 0 is going to be this line right here. When I hit my graph, that would be right there. It looks like it goes through at 4. F of 0 equals 4. If I plug 0 in here, 0 cubed plus 0 squared minus 6 times 0 plus 4. 0 plus 0 plus 0 plus 4 is 4. That's the right spot. Okay. All right. I saw a couple different answers. We looked at them. What do you think? I think it's 10. And again, we could confirm algebraically. Here's negative 1. If I follow that all the way up to where it hits my graph, I think it actually hits up here at 10. And anyone plug it in? If we plug it in, do we get 10? That'd be negative 1. That'd be positive 1, which is going to be 0. That'd be 6. That'd be 4. 10. It's going to be 10. Any questions on looking at a graph and finding our function value? Now, if you had said 9 instead of 10 and I did not give you the function, you're good. Okay? As long as we are close, kind of showing that we know where we're supposed to be looking, you are understanding the concept there. All right. Given a situation, there's a couple things I want you guys to get out of these next two examples. They both involve the exact same situation. And it gives us a story about this graph. It says the function f of x equals negative 5x squared plus 50x approximates the profit a toy company is going to make. And then this is important. It says where x represents the marketing cost and f of x, or y, represents the profit. And the last part, again, is something that you're going to want to pay attention to. Both cost and profit are measured in tens of thousands of dollars. So what's going on is they clarify in the story / in the picture as well of the graph that the numbering is a little misleading. This says 2, but it actually represents how much? 20,000. Okay, so just be cautious on that. Now, the question is asking us, use the graph to estimate the profit when the marketing costs are 30,000. Okay, so then I'm going to go back up to this that I highlighted. Marketing costs here are the x's. So they're saying when x equals, okay, now do your math here. If marketing costs are 30,000, if it's in tens of thousands, x is actually what? 3. So they want us to look at it when x equals 3. Well, x equals 3 is right here. So if I follow that up to when it hits my graph, now this really is going to be an estimate because I think it is slightly above 100. Would you guys agree with that? Like 100 and, what would you guess? 105. Okay. So our estimate, which is all they ask us to do, our estimate is that our profit would equal 105. Now 105 is actually 105 10,000s, right? Well, what's an easy way to go to like multiply by 10,000? Add the zeros, isn't it? So it's got 4 zeros. I add 4 zeros. It's actually 1,050,000. Okay, so this is my estimate. My confirm on this one, because they gave me x, is just plugging in 3. And seeing if how close my guess was. Okay, well, let's see. 3 squared is 9 times negative 5 would be negative 45. That'd be 150. Negative 45 plus 150 is 105. So that was a really good guess. Any questions on that? That part is pretty straightforward. It's the next one where they give us slightly different information, and the confirming part that takes just a little bit of a change. So same exact situation, same information. The question changes for us on this one. It says use the graph to estimate the marketing cost when the profit is 1,250,000. Okay, well, if they give us the profit, they are actually giving us the y value, right? F of x equals the profit, or y equals the profit. And if the profit is 1,250,000, on my graph, I'm actually looking at what number on the y-axis? 125, right? Because it's done in 10,000. So I would take away 4 zeros or 4 decimal places, and I would actually be looking at y equals 125. Now, nicely, in my graph, it's numbered in 25. So there's 25, 50, 75, 100. 125 would be this line right here. Follow that over to our graph. It's right here, which would be an estimate of 5. Okay, so my estimate would be that my marketing costs would be 5, which is actually how many dollars? Right, 4 zeros. So it's actually $50,000. I would estimate that it's a marketing cost of $50,000. Okay, now the confirming is a little bit different. And I'm going to go based off of what they gave me, because technically that's what I should do, is confirm using what they gave me. They gave me the y value. In an equation, the y value is right there where it says f of x. So I can replace that with 125. They're saying that my y is 125. What would the x have been? Okay, well, that's an equation I can solve. It's got x squareds, x's, and plain numbers. And if those 3 things exist, I have to factor or quadratic formula to solve, right? To do that, I need it to be equal to 0. And guys, it's going to be way easier if we make our x squared term positive. So that's going to explain why I'm going to move everything to the left-hand side, because if I move everything to the left-hand side, it's going to make that 5x squared positive, isn't it? I would add 5x squared over, subtract 50x over, and give me a positive 5x squared minus 50x plus 125 equals 0. I have to get it equal to 0 before I can solve. Now, we haven't run into this yet this year, but remembering step number 1 of factoring is going to make this problem a lot easier. What is step number 1 of factoring? GCF, you got it, a GCF, and that's going to make it so much easier. A lot easier for me to think through factors of 25 than 125. Lots of good algebra reminders in this problem. All right, so my factors of 25 that add up to -10 would be -5 and -5. And this is my last good algebra reminder for you on this problem. At this point, we have kind of 3 terms going on, 5, x minus 5, and x minus 5. And we're supposed to set those things equal to 0 to solve for x. Do I have to set the GCF equal to 0? Not in this problem, right? Sometimes, but not in this problem. And it is 100% dependent on, does it have a variable? At this point, we set things with x's equal to 0. This does not have an x. This does not change my answer. Okay? Only things with x's get set equal to 0. And I get an answer. Now it's the same answer on both of them, which is fine. X equals 5, which is what we had estimated, confirmed our answer. Questions? Okay. The last part of today is going to be all looking at graphs and deciding on domain and range. So still focusing on our domain and range. The other day when we were talking about domain, we were given a function. Now you're going to be given a picture. So just a reminder, domain is our x values. Your numbers will come from your x-axis. You will start with the farthest left your graph goes, all the way to the farthest right your graph goes. Range is our y values. That is going to come from our y-axis. It's going to be the lowest point on our graph up to the highest point on our graph. I will remind you that if we put a bracket by a number, that means we include it. If we put a parentheses, that means we don't include it. And that can also be an infinity. I'm going to give you a couple hints. If it's an infinity, it would be at a place on our graph where there was an arrow. Arrows are going to mean infinities, some kind of an infinity, positive or negative. If it's wanting me to not include a number, that's going to be an open dot. If it wants me to include a number, that's not as easy for me to mark up here. Sometimes it will have a closed dot, sometimes. Sometimes it will look like it just kind of hits at that point. And if it looks like it kind of just hits at that point, but you're not sure, it's actually hitting at that point. If they don't want me to include something, they will always very clearly put in an open dot. Okay? So if you're unsure, include the number. If it's an open dot, don't include the number. Okay? Let's look at some examples here. One of the things I want you to look for when you guys are looking at these graphs is those little like slanty arrows, not a perfectly horizontal or perfectly vertical one like this guy. This guy is kind of a slanty arrow, and little slanty arrows mean that they are continuing in 2 directions. This is going to continue in both directions that it's kind of going. So that means it's going to go left forever, and left forever is negative infinity. And it's going to go down forever, and down forever is also negative infinity. Okay? So keep an eye out for those little slanty arrows because that can help us. Let's talk domain first. So domain, I'm going to be moving along my x-axis, seeing how far left and how far right my graph goes. Look for those arrows, infinities, and I can see down here in the left-hand corner that our graph does actually go to the left forever. So the farthest left this is ever going to go, negative infinity, right? And if I get on my graph then at the left and I go along my x-axis and continue along my x-axis as I trace my graph here, so I keep going along my x-axis, keep going along my x-axis, keep going along my x-axis, it stops right here. So that's where my interval is going to stop. It started at negative infinity and it goes all the way up to the x value of 3. Bracket or parentheses the 3? Bracket. Close that. Okay. Domain is always easier and more natural for us because it is reading a graph from left to right the same way we've been trained to read anything since we were little. Range is a little harder. You're going from bottom to top, but it is not necessarily from left to right. Okay, so make sure when you do range that you scan the whole picture for the lowest point. With that being said, this one does start on the left, so it does kind of play into our whole left to right thing nicely. The lowest point is that arrow that's going to point down forever. So this graph does continue down forever. Our lowest point would be negative infinity. And then if I trace along, I'm going to use a different color here, trace along my y-axis as I follow my graph, the highest point we get to is going to be right here at 2. And it happens twice. That has 0 impact on our answer. But that's the highest point in our graph. Now, this is exactly what I was talking about when I said if it kind of looks like it hits at that point, it hits at that point unless they clearly put an open dot. Does this actually include 2? Yes. If they didn't want us to include 2, they would very clearly put an open dot there. So if you are questioning it, it hits at 2. Okay? Lowest point, negative infinity, up to 2, including the 2. Graphs like this, continuous graphs, easier to identify our domain and range. It's the piecewise that get a little bit tricky when we're doing our domain and range. So we'll do a couple of these as well. You really have to pay attention to, am I going up or down, right or left when you're doing piecewise functions. Okay, so let's talk about our piecewise function domain. The farthest left, I'm going to identify this for us. Heads right forever, which is infinity. Heads down forever, which would be negative infinity. Okay. The farthest left this graph goes is going to be here. And it starts here. And as I trace along that little piece of graph, it ends here, right? But my next piece of graph picks up at that exact same x value and continues on. So do I actually have a break there in my domain? No, I don't. It just gets to keep continuing, and it actually is going to continue on forever to infinity. So it's really only one interval that starts here at -3 and goes to infinity. Bracket or parentheses at the -3? Parentheses, open dot, right? It tells me don't include. Open dot is a parentheses, kind of like you're starting to draw an open dot there, right? Range is a little bit trickier, so let's talk about our range on this one. This is an example of what I was talking about. It kind of goes against what we want. We want things to start on the left. Our lowest point on this one is all the way on the right, isn't it? Here's our lowest point. It starts at negative infinity. And if I start tracing that piece of graph, it's going to go up to here. My next piece of graph does not pick up until here. Do you see how I made a jump along my y-axis? That means there's going to be a jump in my intervals along the y-axis. So we go from negative infinity up to -1. There's an open dot there, so we would not include it. Then I end my interval and I start a second interval where my next piece of graph starts. Well, my next piece of graph starts up at +1. And this one's also kind of unique. It's a horizontal line. When talking range in a horizontal line, it doesn't go above or below that. It is just at that value. To show that, it would just be a single number inside of brackets. We'll try one more piecewise before we get out of here, okay? Any questions on that one? This one's pretty straightforward. I'll let you guys try this one on your own before we do our last one, which is one more piecewise. You do have a picture for that last one, so if you're done and waiting, you can go ahead and glance at that last one and see what you think. Okay, let's go ahead and check our domain and range on these. This first one, again, these little slanty arrows mean 2 directions always. So I would look at what those directions are. And then again, one at a time, domain and then range. Domain, farthest left is negative infinity. Although it kind of cusps right here, we don't stop and it just continues going. Farthest right would be positive infinity. This domain is everything. The range, this is again another great example of what I was talking about. Doesn't it look like it gets pretty close to 2? Does it actually get to 2? Well, if they don't want it to get to 2, they're going to put a very clear open dot there. So yes, it gets to 2 right here, and I would say that it includes 2. And then as I trace, it doesn't matter if I trace to the right or the left on this one, the piece of graph is going to head up forever, so it would continue up to infinity. The last one is our piecewise, and again, break it down by domain and range. Right and left first, up and down second. The farthest left this graph is going to go is going to start here, and as I trace that little piece of graph, it stops here, and it doesn't pick up again until this one. So notice we've got a break between our sets, right? So we're going to have a break between our sets. But then as I trace here, that piece goes up to 4, picks up again here, and we get to keep going. No break after that, right? So you should have a domain of open dot at -8 up to closed dot at -4, break until the next piece of graph picked up at -2, which is an open dot, and then it continued forever to infinity. Then the range, now to my y-axis. The lowest point we're going to see is happening right here at -6. And as I trace that piece of graph along my y-axis, you can see that that piece of graph alone heads up forever. So that kind of covers all of the possible pieces in that one. Open dot at -6 and then up forever overlaps all the rest of your pieces, and that would be your range. Any questions on that? All right, for your assignment, I did have a note up here that says on number 8, read the scale carefully. Similar to the one we did in class where the story kind of adjusts the scale. It wasn't 2, it was 20,000. Same thing's going to happen in your assignment.